Welcome to the shop. Well, the inlay is proceeding nicely, and now it's time to cut the inlay pieces that will house the glass pieces. And this is a slightly more difficult thing because the glass isn't perfect. And so what I did, I took the pieces, which are not the same size, they're not perfect hexagons, they're not straight, they're handmade. I labeled them so I could keep track of which one is which, then put them on a flatbed scanner and scanned them. Then took the scan, put it into the CAD system, kind of traced the outline to make a CAD drawing, and then converted that into toolpath. So I'm going to be following my same procedure that I always follow, which is to cut a test piece on MDF, and then once the test piece fits, I'll go ahead and cut my wenge pieces, which are glued to MDF substrates. So I'm going to remove these from the work table. Router bit changed. I'm still waiting on my automatic tool changer that should make the router a lot more usable. Okay. Using the 1/2-inch router bit, this is a carbide tipped router bit, not a solid carbide. And it works fine enough. Yeah, hard to do all this with the keyboard in the position where I can't quite see the router bit, so here we go. Finger on the stop button. Oh. This is not good. We have a problem. So I guess it's off to the CAD room, try to figure this one out. Wrong post processor. Had it configured for the mini mill and not the router. So many things to get right in this process. I use the same cam system for the mini mill, the Bridgeport, and the router, and each one has its own post processor, of course. And let's try this again. Finger on the stop button. Looking good. Doing a ramp in. Hate that dust. Probably could increase that ramp speed a bit. Probably could increase that feed speed a lot. I don't know why that feed speed got so low. Okay, it looks more or less reasonable, not insane at all. And as usual, as expected, it's a little undersize, which is exactly what I expected, and it's what I was planning on, is to sneak up on it. So I'm going to go add another 10, I think. I'm not exactly sure, and I don't need to do a tool change here. I don't need to recalibrate the Z position because it's the same. Not exactly sure why all of these tend to be about 10 thousandths off, but kind of redoing the roughing operation, cutting air. I actually kind of like it that they all come in about 10 thousandths off, because I kind of like being able to sneak up on the final dimension. But still, I'm curious. I always wonder, well, why? CAD drawing should be perfect. Okay, there we go. Almost. Boy, that's close. Very, very close. And then let's check the outside dimension here. Also very, very close. So take a little more. I suppressed the roughing pass so I can go straight to the finish pass here. Barely taking anything. That was a 5 thousandths. Almost. Boy, that is just so close. And that is probably a little too small, so make this one bigger, and of course I can't make this one. I can take more off this. I can't put more back on here, but I will put it on in the toolpath, so when I actually cut the finished piece, I'll have a second chance of getting it right. Okay, hopefully, with any luck, this will be the last adjustment, and then after this, I'll go ahead and make one for real. Don't need to do the outside because it's already too small. Woodwork to metalworking tolerances. Boy, that piece of glass just fits in so nice. I love high precision work. So now, take one of my nice hardwood blanks here and wedge it into place. The wedge clamping scheme works really, really well. And I want to make sure that my hardwood is correctly measured, so I'll go ahead and re-enable tool change and put the roughing operation back in. Hey, at least I get a lot of exercise walking back and forth between the shop and the CAD room. So let's try this again, hopefully for the last time. If we got a better fit here. Went too far the other way. But that's good. Boy, it fits so tight in the test piece, it's hard to get out. Wow, that's what I like. Nice tight fit. Oh yeah, If I press, I'm not going to press that one in until the job is done because that is just about perfect. So, boy, one more pass. Hopefully, with any luck, this will be it. And of course, for anybody that thinks, oh, CNC machining is easy, the machine does the work. All you need to do is push the button. Well, yeah, once the tool path is perfected, once the setup is perfected, once the design is perfected, all you have to do is push the button. So with any luck, we should have success. And we do. Tight fit. Number one is a successful result, and the other three are going to pretty much be the same thing, so I'm not going to show them. I'm going to turn the camera off, and probably the next time that I turn the camera on, I'll be assembling all the pieces together into the final thing. So, hey, gonna be exciting. See you later. Okay, the components are complete, and I didn't show cutting them off the support on the bandsaw, but well, I already showed that when cutting the test piece, and I didn't feel like moving the camera over to the bandsaw, so oh well. The components are complete. It's time to give them the pox. What do I mean by pox? I mean JB Weld, epoxy. And just gonna squirt out a little generous blob of this stuff. It's the same stuff I use on when I'm constructing the Inquala conduit, the steel conduit to protect the wires against heat. I use this JB Weld. Good stuff. Of course, I just like the word pox. I'm allergic, and sometimes when I get into a sneezing fit, I say, oh no, I got the snout pox. Of course, anybody who wants to be rigorously correct in their use of nomenclature would realize, oh no, you can't have a pox without a pustule. And so I guess it really isn't snout pox because it doesn't have a pustule. But I still like the word. So just smear it on the pox. This thing, the thing fits so well it probably doesn't even need all this glue. But hey, nothing exceeds like excess. Actually, the title of a song I wrote years ago. And it's a design philosophy that, do it right or don't do it at all. Kind of cold out in the shop. I hope the epoxy doesn't mind. And like I said, it doesn't need a tremendous lot because there's really not going to be any forces acting on it. And, oh, that fits so nice. I just love precision work. There is just nothing better than precision work. Look at that. Into place it goes. And I didn't mix up enough pox. So I need more pox. I think that's actually a Shakespearean insult, a pox on you. Of course, you know, real pox is bad stuff. I mean, fun to joke about the pox until you get it. Nobody wants a pox. But it is a cool word. So, in they go. Then after the epoxy sets, I'm going to be running the whole thing through the drum sander, which will give a very, very nice surface, and then going to give it a light finish. Doesn't need a heavy finish. I'm going to give it a light finish, probably with an oil and varnish blend, probably Armor Seal. Not really sure how the Armor Seal will get along with the aluminum, but hey, that's R&D for you. You never know until you try. So they are numbered and they are oriented so that the glass pieces fit in nicely as designed. And of course, all of this stuff fits so nicely. And now, just because I can, I'm going to give it just a little bit more to fill up. There's almost no gaps in this. The fit is very nearly perfect. But very nearly perfect is, of course, not perfect. So I'm going to use the old digital method here, the old digital applicator. Just kind of smear in a little bit. So the whole thing, the inlay pieces were cut to be about 50 thousandths proud of the surface. And for those who have never heard the word used that way, commonly used in woodworking, metalworking, and the various other crafts, when one piece is kind of sticking out a little bit, it's referred to as being proud of the surface. Not a bad term. I've heard worse. I don't like to mix up too much of this epoxy because, you know, once it's mixed, can't go back in the tube. So I just kind of mix what I need, and if I need some more, I mix some more. It's definitely misbehaving a little in the cold here, but I think I'll probably take it into the heated office space as soon as I finish kind of poking in the little bits here. And no, this probably wasn't necessary at all because everything fits just perfectly, but hey, sometimes I just like to give it a little bit more. And that, I'm going to probably clean up a little bit around the edges where I've been a little sloppy. And that is the object. Next step, after the epoxy cures, off to the drum sander, then the finish, and then put the glass in place. So, see if I can get on camera here. Oh, see you later. Okay, it's getting close now. Boy, oh boy, we're going to finally see what the thing looks like. Well, not completely because it doesn't have the glass yet and the wood hasn't been finished, but going to sand off the top layer of epoxy on the drum sander and hopefully have a nice time revealing what this thing looks like. Kind of doing a super, yeah, there we go, super rough adjustment here. I want to be somewhat careful with this. Oh yeah. Yep, working exactly as planned. Taking very light cuts. Using an 80 grit sandpaper on the drum. And that is getting very close. Taking very light cuts. The friction material here, I'm not sure it sticks to aluminum super well. And after all this work, I'm just taking it easy and being very careful. And I believe that this is the result. And yes, I am happy. Came out very nice. So I'm going to probably, for anybody that's interested in seeing how the drum is changed, I'm going to go ahead and change to a fine grit. Well, actually not that fine, 120. And it's just a matter of carefully wrapping. Now, there's two ways to get sandpaper for this guy. These are what they call pre-cut pieces. And as you can guess, pre-cut means you just take them out of the box and put them on. Of course, they come at a premium price, and for a shop that does a lot of this work, it's a lot less expensive to just buy a roll of sandpaper and then cut it to size. The cut is not that difficult to make. Probably a simple template and some sort of scissors that can withstand cutting sandpaper without being destroyed. All it needs is a little kind of a tapered edge. So get that end in place, and there we go. I'm going to finish the sanding of this object by hand. Probably going to sand it by hand to a fairly high grit. Probably going to sand it to 600 grit, maybe even more than that. But so far, we have complete success, and I believe it's looking very, very nice. So I'm going to turn off the camera. Hand sanding really isn't that interesting to watch, and so I'm not going to show any hand sanding. Then I'm going to do some experiments. I'm not exactly sure what finish I'm going to use. This, like I've been saying through the whole series, this is R&D. It's the first time I've tried one with glass, wood, and metal all kind of this close together as an inlay. So don't know exactly what kind of finish I'm going to apply. The choices are, I can use conversion varnish, which is what I use on Inquala handles and what I use on my other wood parts of the sculpture. And conversion varnish works exceptionally well on wood, but yeah, I'm not really sure. It doesn't seem to get along with metal that well. Another possibility is one of the various oil and varnish blends, and that those kind of things include things like Watco and Waterlocks and Armor Seal. I kind of like Armor Seal. It's worked well for me in the past, and I may take a little test piece and sand it to the same degree of smoothness and apply some armor seal to it. And I'll probably put some armor seal on a piece of aluminum. Armor seal, the process of applying armor seal is a slow one. You put on a coat, wait overnight, put on another coat, wait overnight, and a really nice finish requires, oh, I don't know, 6 coats or something. So that means, 6 days of work before the final result is achieved. Anyway, I will keep you all updated and see you later. So I decided to try armor seal, and here's what the piece looks like after sanding to 400 grit and applying the first coat. It's going to take probably 6 coats to build up the thickness. The armor seal is an oil and varnish finish, and the advantage of that finish is that it's possible to wipe it on without getting dust problems, or without having to break out the spray rig, or without having to have brush strokes. The disadvantage is it produces a very thin film with each application, so it requires, I don't know, 6 coats or so to really start looking nice. Here's how it looks after 1 coat of armor seal, and the next time that I show it, it will be finished and have the glass installed. Actually, I may show some video of making the base, but the base isn't that horribly exciting, so maybe not. Anyway, that's the end for today. It's been fun.